This video covers Lenz's law. So we have a magnetic field pointing into the page. We then place a movable conducting rod on top of a set of fixed conducting rails. And if we move the conducting rod to the right, we know that the charges will separate themselves because of electromagnetic induction. So let's use the right-hand rule to find the direction of the current established in the conductor if it moves in the magnetic field. So we place our fingers into the page, our thumb with the velocity, and we find that our palm faces upwards. So this means that the positive charges are pushed upwards. The flow of positive charges is also known as the conventional current. So the current we know is in the same direction that the positive charges are pushed. Since this conductor was placed on a set of conducting rails, this current, or flow of positive charges, continues throughout the entire rail system. So next, we can apply the right-hand rule again, but instead of our thumb going with the velocity of the rod, we place it in the direction of the current. When we do this, our palm faces towards the left. Therefore, the conducting rod feels a force to the left. This is Lenz's law, which states that an induced current will flow in such a way as to oppose the change that caused it. So the change that caused the current was the movement of the rod to the right. Therefore, the velocity of the rod created the current, which then in turn stopped the rod from moving, since a force was exerted on it in the opposite direction of the velocity. Essentially, the velocity of the rod and the force from the current will always point in opposite directions. So let's do another example. So here we have a magnetic field pointing out of the page and a conducting rod moving to the right. We first apply our right-hand rule to determine the direction of the current within the conducting rod. Our fingers go out of the page, our thumb points to the right, and our palms face down. Therefore, the positive charges flow downward. And the polarity of the rod looks like this. We know that the current is the flow of positive charges, and since the positive charges move down in the conducting rod, so does the current. We lastly want to find the force on this moving rod. To do this, we apply the right-hand rule again, but the current goes with our thumb, or the moving positive charges. When we do this, we find that our palm faces to the left. And as you can see again, the force is in the opposite direction of the velocity, which is another example of how Lenz's law works.